Morning, CCTI AP Calculus. Mr. Pashar here. I hope this video finds you well and healthy and safe. As you continue your studies in calculus leading up to the AP exam in May, this topic here is on another technique for integrating, which is what we call integration by parts, and it corresponds to section 6.1 in your textbooks. I sent you this assignment, so we'll talk about that a little bit later. But to this point, you've learned a lot of methods for integrating. Reverse power rule, the different trig formulas. We used U substitution, logarithms, e to the x, all of those. But sometimes those things break down. For example, one of the formulas you know from a definition is the integral of ln of x dx. Right? Now, to this point, we can't integrate something like this. We know what this is. This is x minus x ln x plus c. But to this point, we only know that by memorization. So today we're going to learn how this new technique allows us to integrate something like this from scratch. A very useful technique as we go forward. So where exactly does integral by parts come from? Well, interestingly enough, as I mentioned before when we were still in class, is the fact that for every differentiation formula, we actually have an integration formula. And if we think back to derivatives, say we want to take the derivative of f of x times g of x. That's known as the product rule. So remember how the product rule says, derivative of the first times the second plus the first times the derivative of the second. So that's our formula for differentiating. The product rule has a counterpart in integration, and it's called parts. So suppose we have the integral f of x times g prime of x dx. What does this look like in terms of an integral? Well, here's what it is. It's f of x times g of x minus the integral of g of x times f prime of x dx. So for short, you'll always hear me say fg minus integral gf prime. And this is the format that will allow us to evaluate an indefinite integral and then later a definite integral using parts. Okay, so it seems a little bit confusing, but I'll show you a very tabular way to do this. It's a little bit easier in the textbook. I just stick with f prime, g prime, and g. The textbook uses uv, du, and dv, the differentials. But I'll show you guys a little bit of a shortcut to handle this. So let's look at an example to get started. Let me clear this away too. Say we want to integrate x times sine of x dx. So now here's an integral x sine x dx that, well, kind of run into a little bit of a problem. It's like a product, right? Two things being multiplied. If we let sine of x be our u, that becomes cosine. That's not going to knock out the x. And if we let u be the x, well, that's not going to knock out sine of x. So that just gives you 1. So we're going to use parts. And here's how we set it up. I'm going to have f prime, g prime, and g. Okay? So what we got to do is pick functions f and its derivative, g prime and its integral g. Now the question is, what do you pick for f and g prime? What do we pick? Because you have two choices. Typically, you want to pick the easier of the two for the derivative to start off. And this one isn't so bad because you have a linear function and a trig function. So usually the trig function, depending on the situation, we can integrate that easily. We can also integrate the trig function easily, but we have an x. If we let x be over here for g prime, then to integrate that, that's going to give you 1/2 x squared. That's a little more complicated than if we let sine be here, and its integral would be minus cosine. So we're going to take f to be x, because look how nice this works out. The derivative of x is just 1. G prime will be sine of x, and its integral is minus cosine x. Now, if we would have done it the other way, this would have been sine x, cosine x, x squared over 2, or 1/2 x squared. This is the format that you're going to want. And when you play around with this, you'll see why exactly we want that. But now we have all the parts essentially, so we're just going to write the format. So in very short notation, this is equal to fg minus gf prime. So what is f? F is x. What is g? Minus cosine minus the integral of gf prime. So here's g, and f prime turned out to be 1, which is really nice. So that's what it looks like when we go ahead and put all of the parts together. So again, let's just kind of recap. These are our parts. This is the formula for integrating by parts. Just like the product rule for derivatives, we have the product rule essentially for integrals, which is parts. We can rewrite this guy now as minus x cosine x minus a negative, so that becomes plus. So we've got plus the integral of cosine x dx. So now all we got to do is integrate this, and this is typically what we look for. What's a warning sign that parts is not going to work? A lot of the times it's whatever integral over here you can't integrate, and you're back to square one. But you know you're in good shape because you can integrate this. So the integral of cosine x is just plus sine x. So your answer is going to be minus x cos x plus sine x plus c. And that's how we do it at the integral by parts. Again, we didn't have any other tools in our toolbox to be able to integrate this thing. So now we're able to by chopping it up into pieces essentially. So I would encourage you to pause the video at this point, go back and see if you can do this problem, and I'll step back in a moment. Okay, welcome back. So I'm hoping you're able to take care of this problem. So let's look at another problem. This is one that is also in your lecture notes that we couldn't do before. Something looks so simple, the ln of x dx, we want to integrate it. It looks so simple, yet by all the rules that we have, we can't do it quite yet, okay? So, we want to use parts. So we have f prime, g prime, and g. Now, what are we going to pick here? Because to me, I only think I have one function, but you actually have two. You have ln of x, and you have the number 1. Now, what we cannot let happen here is we cannot let one of these things become a 0. Because if one of these things on either column becomes a 0, then we're going to be in trouble. It's going to negate a whole integral or a whole part of the thing. So in this case, we're going to let the ln of x be something familiar. That's going to be f. So we're going to let f be the ln of x, because we know what the derivative of ln of x is. It's 1 over x. So f prime is 1 over x. G prime is going to stand for 1, because we have 1 times the ln of x. So that means if we integrate 1, we get x. So these are the parts that's going to allow us to work for us. And again, if you don't believe it, go back and switch them and you'll see you run into trouble. So the formula says we want FG minus GF prime to round up all the parts and go and put everything together. So what is F? F is the ln of x. What is G? That's x, so that's ln of x times an x, minus the integral of GF prime. So G is x, and F prime is 1 over x. So it's x times 1 over x dx. Okay? Now we certainly catch a break over here because x times 1 over x is just 1. So we got the integral of 1 dx. How sweet is that? That's nice. This over here I'm going to rewrite as x ln x. This is going to be minus x plus c. So the integral is going to be x ln x minus x plus c. And that's how we integrate the ln of x dx. So again, we had no methods up to this point to allow us to do such a thing. So again, I would encourage you to pause the video, go back and see if you can integrate something like this. And by the way, you're going to see a lot of functions that pop up with the ln in it. You know, so ln is usually going to be your pick over here for f, and then take its derivative. So I'll step back for a moment, and let's see if you could go ahead and redo the problem. Okay, so I'm hoping you're able to take care of this. I'm going to show you one more for today, and then I'll come back in another video and show you how to handle some other ones. But I'm going to show you one that contains e this time. So here's another example. Something like x squared e to the x dx. Somewhat problematic. At first glance, you may think you could use substitution. You can't, though. If you let u be e to the x, that just gives you e to the x back. We'll never knock out the x squared. And if you have x squared as u, and you make that 2x, then nothing's going to cancel out. So this is a perfect candidate for parts. So we've got f, f prime, g prime, and g. So what do we do here? Well, e to the x is usually a very good candidate for g prime, usually. So if you integrate e to the x, you get e to the x again. We're going to let f be the x squared because that behaves nicely as 2x for the derivative. If it's the opposite way, sure, e to the x will give you e to the x as the derivative, but then if we make g prime x squared, then what happens is now you're going to have 1/3 x cubed, and that becomes a little more problematic. So let's put our parts together. So we've got fg minus the integral of gf prime. And we're going to have f, which is x squared, times g. So you've got x squared e to the x minus the integral of e to the x times 2x dx. Okay? Now, I want you to stop and take a close look here, what we get right here. Do you notice this is going to be a problem? The integral of e to the x times 2x dx. Because substitution is not going to work here, right? Can't use substitution. So guess what has to happen? We have to use parts again. So we're going to have to go ahead and use parts a second time for this guy right here. So I'll do this in another color. So this integral we have to figure out and then kind of attach that answer back onto this guy here. So we have an e to the x and a 2x. Once again, I'm going to let the easier to 2 be the integral. So as e to the x, we're going to have to integrate to get e to the x. And if we take 2x to the f, this works out nice because f prime is 2. Again, if you don't believe it, switch it, and you'll see that it becomes a little more complicated. So for this guy, we have fg minus gf prime, the integral. And what do we have? F is 2x times g, which is e to the x, so that's nice, minus the integral of gf prime. So that's going to be just 2 e to the x dx. And now you see we don't have a problem with this integral anymore. Because that just flushes out and it becomes 2x e to the x minus 2 e to the x plus c. So this piece now, right here, that's going to go right here. So your final answer is going to be x squared e to the x minus, I'm going to put a bracket, and I'm going to write in 2x e to the x minus 2 e to the x, close bracket, plus c. So you may not be able to see. There you go. There's the rest of it. So this would be your final answer right here. So this is an example that's kind of classic in the effect that sometimes you do have to use parts 2 times. You have to use parts 2 times to wrap up the whole problem. And I mean, what can you do here? Yeah, if you want to be technical, you could distribute the minus, change the signs, and if you wanted to factor something out, you could, but who really wants to do that? It's really not necessary. So this is the conclusion of this first video. I'll have another video on parts for you guys. I hope this helps you a little bit. Until then, try your best. Until next time, please stay safe. Enjoy the rest of your day, and I will see you when I see you.